Introduce, this is my team.
Assalamualaikum warahmatullahi wabarakatuh. The Honorable Sri Kadarwati SSI MSc PhD and Stephanie Diah Pamilesari SSM Hum as lecturers, English course, and friends that we are proud of. We are from group 5 with members. The first one is me, Galang Purnama, and my team, Tuyarni and Af'idatul Ulya. Okay, today group 5 will present a journal with the title Introducing Atomic Structure to First-Year Undergraduate Chemistry with an Immersive Virtual Reality Experience. Friends, we are hoping that you can follow our presentation until the end. Thank you. Alright, let's get into the first discussion, which is opportunities for visualization in chemistry education. Chemistry is a science that incorporates many abstract concepts and terms, making it challenging to understand. Some sciences are more challenging to understand than others because of the number of abstract concepts and terms. Chemical compounds exist in reality, but we cannot see their molecular structure with our bare eyes. The deeper we go into ordinary things, the more problems we meet in visualization of small particles. This is a common problem for chemistry, physics, and biology. So we need some technology that helps us to visualize molecular structures for us to see. Okay, in this research, use AR or augmented reality and VR or virtual reality. Now, in AR, add digital elements to a live view, often by using a camera on a gadget, while in VR, it implies a complete immersion experience. So, with AR and VR, it can allow improvement of science course at school or university, and some of them even include a laboratory component. Most of the things that are introduced in a chemistry laboratory are macroscopic by nature. Nevertheless, chemistry cannot be fully understood without going to the submicroscopic level. It is considered that chemistry consists of 3 components, which can be considered are corners of a triangle. Number 1, the microscopic and tangible, like what can be seen, touched, and or smell. Number 2, the submicroscopic, like atoms, molecules, ions, and structures. And number 3, the representational, like symbols, formulas, equations, molarity. So, in the present study, we incorporated VR chemistry simulation of atomic structure into the classroom for undergraduate students in order to describe its implementation and show how it enhances learning. We can see in figure 1. Can be seen in the VR implementation in figure 1 to see the sulfur structure. On the left is the molecular structure of sulfur without VR, while on the right is using VR. It can be known that by using VR, the molecular structure of sulfur is more visible from the microscopic side.
Okay, number 3, NEL chemistry VR relations. NEL chemistry VR includes relations that all learners to get a complete immersive experience with the ability to interact with the virtual reality objects. The software supports mobile VR platform, including Google Blackboard, Oculus VO, Gear VR, and Pico VR, and can be run in non-VR mode on cyber. Each lesson is 3 until 7 minutes long and can be integrated into the class-based lesson flow, making the subject more visual and comprehensive. Each lesson starts in a lab and resumes in the molecular level, including the lesson dedicated to orbital named figure 1, like Galang explained, or artistic rendition of Bohr's model in the figure 2. use of VR technology has overcome one of the main difficulties in chemistry education, connecting the macroscopic and microscopic world in an overall concept and saying how they are linked. And then, implementation of MEL chemistry VR lesson in the classroom. What is the main goal of this work? The main goal of this work was to show that after visualization, children will have a better understanding of the structure of the atom, because this concept is often confusing to students and difficult for the teacher to explain. The MEL chemistry VR laboratory called Make Your Atom is a practical activity that provides the student with the opportunity to build any atom of any known stable isotope of elements called hydrogen to business, as technetium and promethium. This lesson is implemented into a chemistry classroom with 43 first-year undergraduate students studying chemistry at ICMO University in September 2020. Step of implementation, the MEL chemistry VR is every student to part in the pre-test, the VR experience, and the post-test over the course of 2 academic hours. The maximum possible test score was 16 points or 4 points per element. In this evaluation, there is a bar chart showing the percent of student progress based on comparison of pre-test and post-test score from lowest progress to highest. From the bar chart, pre-test and post-test were conducted to evaluate the impact of the VR experience on students' understanding of atomic structure. Results show it the 27 students scored higher on the post-test, indicating improvement in understanding atomic structure. The average score on the pre-test was 6,000 plus minus 2,930. And on the post-test, it was 9,260 plus minus 2,901, indicating a 20.3% average progress. Statistical analysis using the two sample student t-test show a significant difference between the pre-test and post-test score, with a calculated value of 5. Therefore, the implementation of this technology to chemistry classes is able to help the understanding of the atomic structure through realistic visualization that students can see in computer models such as MEL chemistry VR lesson.
The present technology report indicates that the implementation of an immersive VR experience involving atomic structure, periodicity, and predictable lesson can considerably influence learning outcomes of students. Therefore, the VR experience can be seen as a usable tool for enhancing students' understanding of chemical concepts, and it is essential for a better perception of abstract notations that cannot be otherwise visualized in full detail. Interaction with particles, atomic nuclei, atomic orbitals, and atoms can facilitate the learning process of difficult chemistry concepts by visualizing these objects in the immersive VR or virtual reality.